Once again, welcome to my channel, Arun Kumar Exam Guru. This video is on engineering mathematics. I will discuss some common applications of matrix operations. Please watch till the end of this video, because at the end of this video there is a short animation, and please don't miss out this animation. What is matrix? Matrix is a rectangular table of values arranged in rows and columns. If m is the number of rows and n is the number of columns of matrix, then the order of matrix is m by n. For multiplication of two matrices, the number of columns of first matrix and the number of rows of second matrix should be identical. We can multiply two matrices, say A of order m by n and B of order n by p, to get another matrix C of order m by p. I will mention only 4 applications of matrix from engineering mathematics perspective. The first and the foremost application is solving the equations. The second one is to reduce the size or compress the values for computer storage. Number 3, change the magnitude or angle of a vector. And number 4, cryptography. Number 1, solving the equation. It is the most common application of matrix. Let's take the equations having 3 unknowns x, y, z. So these are the 3 equations. Let's write the matrix form of the coefficients of the unknowns x, y, z, and solving for unknowns, you will get the value of x, y, z in the easiest way. So you get the value of x, y, z as 13 minus 11 by 8 and minus 3 by 8 for this case. Number 2, reduce the size or compress the values for computer storage. The computer memory is stored as array of values. The size of the array in matrix form can be reduced by matrix operations. For example, an original array of matrix stored in computer memory is a 3 by 3 matrix consisting of 9 elements. The matrix comprises of values 30, 40, 35, 36, 48, 42, 42, 56, 49. Let's try to reduce it first by making the factors of the values. So after making the factors, or after dividing it into factors, we get from the first row 5 as the common value, and from the second row 6 as the common value, and from the third row 7 as the common value. We are going to take out the common values, 5 into 6 into 7, and the remaining values you will get in the matrix as 6, 8, 7. Now this can be further simplified as taking 6, 8, and 7 from each of the columns. You will get this matrix, or you can arrange it as 5, 6, 7, 6, 8, 7. That is the multiplication of a 3 by 1 matrix with a 1 by 3 matrix. This is the matrix you are getting when you are simplifying it. So from this matrix you get the 3 by 3 matrix had 9 elements, but when we express it as a product of two matrices, we got only 6 elements. Here there were 9 numbers, but on the RHS we have only 6 numbers. Hence the size of the matrix reduced from 9 to 6 elements. And number 3, change the magnitude or change the angle of a vector. Sometimes the vector coordinates, when multiplied by a matrix, there can be a change in only magnitude of the vector, or change in only angle of the vector, or change in both magnitude or angle. To understand that, you have to know the fact that a vector quantity has magnitude and direction. It's convenient to express a vector quantity in coordinate system as coordinates x, y to reveal its magnitude and direction. the vector quantity is equal to xi plus yj, where I represents the direction in x-axis and j represents the direction in y-axis, and it is marked in coordinate system x and y. The magnitude of this vector is given as square root of x square plus y square. The direction of the vector theta equals tan inverse y by x. This is a typical Cartesian coordinate x o x dash, y o y dash. Let's consider a vector with coordinates 1, 2. So this is, let's mark 1, 2 on the coordinate axis, and we mark the vector pointing towards the direction. The magnitude of this vector is root over 1 plus 2 square, that is root 5, and slope theta equals tan inverse y by x, that is tan inverse 2 by 1. You will get tan inverse 2. Now you are going to multiply this vector 1, 2 with another matrix, say 2, 0, 0, 2. You will get the resultant value as 2, 4. 2, 4 is the resultant or the new coordinates. So that means from 1, 2, the value has changed to 2, 4. The vector has increased its magnitude. By how many times? The magnitude of the changed vector is square root of 2 square plus 4 square, that is 2 root 5. And theta of this new coordinate is tan inverse y by x, that is tan inverse 4 by 2, that is tan inverse 2, which is same as that of the coordinate 1, 2. That means matrix multiplication can result change only in magnitude of the vector without change in direction, which happened in this case. Let's consider a vector with coordinates 2, 0. Let's mark the vector 2, 0 on the Cartesian coordinates. Now let's rotate the vector by 90 degrees without change in magnitude. So if you rotate this vector, we will get the new coordinates as 0, 2. Now how will we change the value of 2, 0 to 0, 2? For that, if we multiply a vector with a rotation matrix, we get the coordinates of the new matrix without change in its dimension. Now what is the rotation matrix? It has a common form, that is cos theta minus sin theta, and cos theta. For this case, the value of theta is 90 degrees, so the rotation matrix is cos 90 minus sin 90, sin 90, and cos 90. You will get 0, minus 1, 1, 0. When we multiply the original coordinates 2, 0 with this rotation matrix, we get the resultant coordinate as 0, 2. In this case, the matrix multiplication can result change only in direction of a vector without change in magnitude. Now let's consider a vector with coordinates 1, 2. The magnitude of this vector is square root of 1 plus 2 square, that is square root of 5. Now let's multiply this matrix, this vector with another matrix, say 3, 1, 1, 2. You will get the resultant as 5, 5. So when we change the direction and magnitude to this new coordinates 5, 5, we can conclude that matrix multiplication can result change both in direction of a vector and change in its magnitude. And number 4 is cryptography. Cryptography is the process of hiding or coding information so that only the person a message has intended for can read it. The art of cryptography has been used to code messages for thousands of years and continues to be used in bank cards, computer passwords, and e-commerce. The art of cryptography can be done with the help of matrices. Let's look at a conversation between three people to understand the concept of cryptography.
Mr. X, I have a work for you. We have our treasure hidden in black box, and we need to send this message to our agent Tessa.
Yes, boss. I will send the message now itself.
But Mr. X, you cannot send the message directly. You have to ensure the message delivered to Tessa is confidential. For that, you need to encrypt the data by certain means.
Okay, boss. Let me find some means to sort it out.
Okay, I am leaving then. I know you are a genius at encrypting, so I am assigning this task to you.
How to encrypt the code? I can use the concept of matrix for encryption. For that, let me find the alphabetic order of the letters of word black box. I have a total of 8 letters. Let me convert it into a 4x2 matrix to make it easy for computation. This is my original matrix, 211, 12, 2, 115, 324. Let me consider another 2x2 matrix as encrypted matrix and multiply it with original matrix. The encrypted matrix comprise of 3, 2, 2, 1. So this matrix, 28, 15, 40, 26, 5, 17, 57, 30, is my code for Tessa. Tessa, these are your secret codes sent by the boss to find the treasure. The codes are 28, 15, 14, 26, 5, 17, 57, 30, and 3, 2, 2, 1.
Okay, Mr. X, it's an arduous task for me then. You have given me 2 matrices. First, let me multiply the 2 matrix to see if I am getting any hint. High values, difficult to get any hint. The values obtained are very large. Let me try some other methods. I will find the inverse of matrix and then multiply. Since inverse of 4x2 matrix is not possible, inverse of 2x2 matrix is possible. Oh, yes, I got it. If I replace the numbers obtained in this matrix with the order of English alphabets, I will get the word as black box.
So you have listened to this conversation. What is a summary of the conversation? Mr. X had an original matrix of word black box, A of order 4 by 2. He multiplied with an encrypted matrix B of order 2 by 2 to get another matrix C of order 4 by 2. Mr. X sent the matrix B and C to Tessa, but Tessa wants matrix A, which is the word black box. So how did Tessa get the value of for matrix A? A into B, we got matrix C, and B and C are known to Tessa. So A is obtained by taking inverse of B and multiplying it with C. So thank you. Don't forget to like, share, and subscribe, and press the bell icon for more updates.